All right, let's see the next topic, the power of compounding. Right, compound interest. Right, compound interest. Okay, so it's two types, right? We have simple interest and compound interest. The first case, I imagine that you deposit $1,000 in money holding service, promises you pay 5% interest a year, every year, right? Simply. That is the simple interest. Well, we see the balance sheet for 4 years, right? That 5% only applies to the 1,000 you're asking them to hold, right? The service, and they'll pay you 5% of what you have every year, right? The same amount, just 5% interest to the $1,000, right? So the spreadsheet, right? The spreadsheet shows, well, after n years, 1 year, 2 year, 3 year, 4 year, the interest payment and the balance in your account. Right? In 1 year, apparently, well, that 5% interest applied to the $1,000, that's $50 interest. So your balance will be 1,000 money you put plus $50, right? That's 1,050. And the second year, still the same 5% apply to the same $1,000 you put in, and that interest is 50. You can see the third year, the fourth year interest is all the same. All right, the interests from year 1, 2, 3, 4 are all the same, are just the percentage applied to the principal, right? The original money you put in. That is called simple interest. Right? The way it is put in is simple interest. So balance on each year just increased by $50 at the end. So you have 1,200 at the end of year 4. Each year is adding $50 to whatever you have. So that way is the simple interest. That's just 4 of the $50 interest paid plus $1,000 you have. And the second case is you place the $1,000 in a bank account that pays 5% interest once a year, and bank adds the interest to your account, right? So the first year, 5% apply to the 1,000 you put to get $50 interest. So at the end, you have $1,050. Right, and the interest paid once a year. So in the beginning of year 2, you have $1,050. Then 5% interest applied to it. So at the end of year 2, you will have $52.5 of the interest amount. And that interest is adding to your balance is 1,050 plus 52.5 to get $1,102.50. Right, so that is a new balance at the end of year 2. Same logic, your starting of year 3 have $1,102.50, and 5% interest is applied to the total balance, right, to get new amount of $55.13 of the interest. And still, the interest is added to the balance of year 2 to get the total balance of year 3. That's $1,157.63. And that's our new principal in the year 4, 5% of it to get the interest, then add the interest to the balance of year 3. We get the end of the 4th year balance is $1,215.51. So comparing the compound interest to the simple interest, that compound, even it pays same interest rate, right? The compound interest is more. Right? We see here in the 5% after 4 years, if they pay annual payment, that's $15 more. Right, but that's just You put in 1,000 there, right? Right, so we can see, right, the compound is a little bit better than the simple interest. Because what? Because the interest is applies to the balance, right? But the simple interest is only applies to the principal. Right, so simple interest formula is easy. We don't have to worry about it, right? We just have principal times the percent rate times how many times it pays, right? That's just the simple interest, then add to our internal principal. While within principal, that is a financial, in financial formulas is the balance upon which interest is paid. So which is the original money, right? Simple interest is interest paid only on the original principal and not on any interest added at a later dates, right? So that is the simple interest. So the example we see before, first example is applying the simple interest. So no matter how many years it passes, the interest rate only applies on the original principal, but not on the balance, right? Only no matter how the balance increases, that's just the original principal applies the interest rate. While compound interest is interest paid both on the original principal and on all interest that has been added to the original principal. Right, the formula is simple, right? That use power of y here, but we can see it's just 5% interest rate times the principal and adds to its principal. So after a sort of calculation, people find it, well, that's just principal times 1 plus the annual percentage rate to the power of y. Right, so A is accumulated value balance after y years. P is the starting principal. APR is annual percentage rate. Y is the number of years. So in other words, the number of payments of interest that the bank or whatever pays you, Right, so be sure, right, to know that the annual interest rate, which is the APR or annual percentage rate, that's annual interest rate, should be expressed as a decimal rather than a percentage when you carry into calculation, right? So percentage given in the question will be converted to decimals. All right, so the question, right? We have $100 invested in 2 accounts, each pay an interest of 10% every year. One account pays simple interest, and the other account pays compound interest. Of course, annually, find out the balance over a 5-year period. Right, so simple interest it's 10% paid on the $100 investment. It's $100 investment times 10% times, well, that's the annual interest multiplied by 5 years. So intuitively, this amount is annual interest times amount of 5 years. Right? So that's total gives the total interest. And plus your principal. Right, so that value should give us the final value. Right? We have 100 multiplied by 10%, that's 0.1 times 5 plus another 100, right? That gives us 150. Right? If you want to know the formula, right, it will be short, simple interest, the accumulated balance, that will be principal times 1 plus rate times year. Right, so if we intuitively, that's the principal times rate times year plus the principal, and when you factor out, that's principal times 1 plus APR times Y. Right, but this one somehow, like, to me, it's not that much useful. So intuitive, you can find it, that's good enough. If you want to use formula to find it, well, it's also okay, right? For compound interest, accumulated value will be principal multiplied by 1 plus annual interest or annual percentage rate, right? APR, not the yield, but the rate. Right, annual percentage rate to the power of Y. My principal is $100. APR is 10%, that is 0.1 to the power of 5. Right, if you want, you could find the 1 plus 0.1 to the 5 power on your calculator. Raised to the power, you can see on the calculator this symbol, a to the b, or someone say x to the y. This is power to the 5. Right, that's 1.61051. So 100 times, that's 161.051. And keep as much as decimal if you want to. And since that's money, right, so keep 2 digits, 161.05. So we can see, right, simple interest method, they get $150, and compound interest, that's $161.05. So it's like $11 more, right, for the investment. Right. So doing that step by step, right? Recommended is to take this part, right? The interest part or the factor itself, like calculate together in your calculator and record down the number, right? So if like if you're getting more used to it, you can do everything one step. That's no problem, right? So on a calculator, if you get used to it, you can do 100 times 1 plus 0.1 raised to the 5th power. You can do that, right? No problem, to get the final answer in one step. But things could be more tricky, right? And if you wish to do step by step, that's also great, right? So let's see the next question, right? This question, you invest 5,000 in a bank account that pays an APR of 3% every year, how much money you'll have after 5 years, five years. All right, that's balance. So we have formula, right? Accumulated value at the end is principal times 1 plus APR to the y, right? Because you have annual payment raised to power of number of payments you have, right? Simply. And what? In our question, we have principal is $5,000. We have annual percentage rate is 3%. That is 0.03. And the number of year is 5 years, right? The term. So that gives us what? 5,000 multiplied by 1 plus 0.03 raised to the power of 5. And we can calculate this part, right? 1.03 multiplied by a certain number. Right? So 1.03 raised to the power of amount it pays. That's 1.15927. 5927 4074. Right, in the middle of the process, recommend is to keep all the digits. Right, 5,000 multiplied to this number. On the calculator, or use computer, I could copy and paste. If you use other things, that's something else, right? So 5,796. Wait, 796. Point what? 37037. And that's the balance, still is the balance of money, 2 digits. Keep. Right, so we got $5,796.37. Right, everything we have is an annual percentage rate paid once a year, right? Once a year. Usually, right, for the bank payment is give you the APR or APR that pays much more than once a year, right? Paid many times. The compound interest rate, interest formula, right, for balance, for interest paid n times every year, which means some account pays monthly, right? Some pays annually, some pays twice a year, some pays every quarter of a year, right? Or the application could be different, right? So that's more than once a year. So the APR is annual percentage, right? That's annual percentage rate. So every time it makes the payment, the rate you need to have is divided by n, right? Because that's annual. So number compounding every year, you need to divide that into the APR to see how much is the rate actually paid every time. Right, that's how you're compounding. And the total number of payments will be year times the number compounding every year, right? So which means if your interest is 8%, like 12%, and you pay annually, that will be 1% every month, right? You get in your bank account. And that if the account paid 12 every year, if that's 5 years, that will be 12 times 5, will be 60 payments you make in total, right? So that's the N and the NY. It's similar as what we see the formula before, right? For annual, it's also correct that annual just have number compounding periods just once a year, and 1 times your year is just the total Y or total year will be a number of compounds. Right, but if it's more than once a year, we use this formula. Still, AP and APR are same thing. The extra is the N is the number of compounding periods every year. Right, so when we have a monthly compounding, that similar thing we see, right? Before we see is the example is annual compound interest that with 3% for 5 years. Here is 5,000 invest, right? APR 3%, compounds monthly, and what is the balance? Right, so the compound interest formula is accumulated is principal times 1 plus APR of N raised to the power NY. Where what? Where the, let me use different color for the given information. Where the principal is still 5,000. The APR we found before was 3%. And this question is also 3%. And the extra thing is what? The N, right? The N, it gives compounds monthly. So every year, that's 12 payments, right? Monthly, you have 12 months in a year. That's 12 payments for every year. And the Y will be number of year of 5. Right, so you have 12 payments every year, you have 5 years. So total payments over here, that will be 60. Right, so compounding 60 times instead of before compounding 5 times only. But here, every time interest rate will be the rate divided by 12. Let's see, right? Do we have any benefit or any deduction, right? Depreciation when we have the compound more than once a year. APR 0.03 divided by 12 raised to the power of what? Power of 5 times 12, right? You could put a little bit parenthesis to show that multiplication. But still, at the end, we'll have a long bunch of numbers, right? So we have what? 1 plus 0.03 divided by 12. Raised to the power of 12 times 5, right? 12 terms, 5 years. That's 1.161616. 782. Right, before we have 1.159, now compounding more than once, we get 1.16 for 5 years. So that's a little bit more, right? Then we have 5,000 multiplied by it. 1.161616782. That's 5,800 or 8 point what? 08391. Right, that's add all the decimal points and you round it to 2 digits. 0.08. If you know you need to round to 2 digits, like you round it directly from the calculator. So here, that's also okay. You could omit this step. But you could do step by step more, right? To show me more stuff in the middle, but what I show you is the necessary ones, right? Okay, so compared to the annual payments, we have 5,796. To monthly payments that we get is $5,808, right? It's like $12 more, a little bit, right? $12 or $11 more. No, yeah, $12 or $11 more. Right. Similar thing, right? Quarterly compounding. You can pause the video and try to practice with that, right? To list out all the information, we have what? We have 2,000 investment, pays the APR 4%, compound every 3 months, right? Which is quarterly, and how much you get after 6 years. All right, so try that now. You can pause the video and try that now. Okay, so I believe you have tried, and let's see if it works. Get the answer, right? Principal 1 plus APR over n raised to the n times y power, right? And in this case, the principal is $2,000. The APR is 4%, which is 0.04. N is number of payments. Y is clearly showed as 6 years. N is the number of payments every year, right? So if say payments is every 3 months or every quarter, that means every year you will have 4 payments. Right, it makes sense, right? Every year is 4 payments. Right, so 2,000 multiplied by 1 plus 0.04 over 4 raised to the power of what? N times y. N is 4 payments, y is 6 years. Right, so that's power. If you want to show more steps, right, that's fine, but you could see, right, 0.04 divided by 4 is 0.01. 4 times 6 is 24, right, the power. Right, so 1 plus 0.04 over 4 raised to the power of 4 times 6, or what we found 1.01 raised to the power of 24. That's same, right? Just another step, 1.2697. Three, 4, 6, 9, 4. 3, 4, 6, 9, 4. 6, 4, 9. Wow. 6, 4, 9. All right. That's 2,000 multiplied by the answer you have. Still, on your calculator, you may see as the ANS as the previous answer, right? So you could use that or this one. Right, previous answer. That's 2,539.469. Or if you know already, you're gonna round it into 2 digits decimal. You could directly round into 2 digits, so don't have to write again, right? 2,539. 47, right? Since the next digit is 9, so that will be 47 cents. So that's quarterly compounding. And semi-annually is the next question. You can also pause your video and try to practice with this one. Okay, so let's get back to do it. 800 invest APR 6%, compound semi-annually, which means twice a year, right? Semi-annually. After 14 years, how much you get? So same formula, principal times 1 plus APR over n raised to the n times y, where the principal is $800, APR is 6%, n is the amount you get for annually, right? How many times you get paid. That say is compounds semi-annually, which means every year you get 2 payments. And after 14 years, how much you get? Right, so let's see. Principal 800 multiplied by 1 plus 0.06 over 2 raised to the power twice a year times 14 years. I still recommend to get the whole thing done together. Okay. 1 plus 0.06 divided by 2 raised to the power of 2 times 14, right? That's 2.2879. $27676. Right, so I multiply 800 by this number. That's 1,830. Right, if you want to record this whole number down, that's totally fine to me, right? 3, 4, I mean, that's actually better because I can see your middle steps, right, to see what's going on. Right, then finally, $1,830.34 is what you get, right? The longer you make, the higher APR it is, and the bigger amount of payments annually you make, right? The bigger compounding it has, then it will yield to larger final balance. Right, even though you have a denominator at the rate over here, but this n is also on the power, right? So it has more effect on the power than on the denominator, right? So when you put in that whole number, the larger n is, the larger y is, the larger APR it is, or the larger principal it is. Actually, principal is another effect, right? But this is a factor, right? No matter the principal is, that's still the ratio of it, right? So this one is that's the factor. The larger value of APR, n, and y is, the larger value your accumulated value will be, Right, and then, let's see the annual percentage yield. The annual percentage yield is the relative increase. That is absolute increase over starting principal. Right, the annual percentage yield is actual percentage by balance increased in a year, equal to the APR if interest compound annually, and it's greater than the APR if interest is compound more than once a year. Right, so we have the previous example, right? That's interest compound a year, and the interest compound more than once a year have a different final balance, right? Which means this one has $808 interest and annually just $796 interest. That is different. Right, but APR is also annual percentage yield, right? So it's just in the view of 1 year. Right, so compounding. More compounding means a higher yield, right? Means a higher yield. Means it have interest more, right? Invest 1,000 into account that APR is 800. You get monthly compounding and daily compounding to see what's going on. Right, first part we see monthly compounding. That accumulated value, I will not do it slow. I just assume we get the formula well. Monthly compounding, that's divided by 12. And the accumulated value is just accumulated for 1 year, right? So to find the APR or APY, annual percentage yield, we just find the 1 year payment. 1 plus 0.08 divided by 12. That thing raised to the 12th power. Right, that's 1.0829. 99507. Right, so multiply by 1,000, that's 1082.999507, which in money that's what? 1,082.83.00, right? We round it, that's affect everything, that's go to $1,083.00. And the annual percentage yield we see is absolute increase over starting principal. Right, so absolute increase, or in other words, is the interest, is $83. And annual percentage yield, that's $83 divided by 1,000. $0.083 times 100% to get 8.3%. Right, so we have 8.3% for the monthly compounding. And similarly, daily compounding, let's make let me draw a vertical line between to distinguish it so I can use the enough all the spaces I have, right? Principal times what? 1 plus 0.08. Well, usually in financial world, assume day is 360 days a year. Doesn't matter, right? We just use 365 for our case, doesn't really matter, right? Just use 365. Principal, yeah, principal is 1,000. Right. And this number, it looks messy, but when we have calculated, it's just no, more or less it's the same idea. Right? 1 plus 0.08 divided by 365 raised to the power of 365. Well, it's same 1.08, but like afterwards it's different. right? 3 to 7. 3 to 7, 7, 5, 7, 2. Right, so 1,000 times it. And round it directly, 1,000, 3.28. Right, and then interest. That is $83.28. Right, when we have the same idea as the accumulated value, take away 1,000. Then this annual percentage yield, 83.28 over 1,000 is what? 0.08328 times by 100%. That's 8.328%, or if you want to keep less digits, that's 8.33%. Right? It's a little bit more, right? So higher compounding means higher yield. Right? Higher compounding means higher yield. But that yield has a limitation, right? Has a limitation. So next. Next is about the continuous compounding, which is a compound interest formula for continuous case, right? That is the limit of maximize the compound you can take. Like every second or every moment you put your money in a bank, that makes a compound payment. It's not like every day, every month, every short moment you can imagine. Right, like between seconds or the moment is much, much smaller than the second, right? Every moment it is increased. But the limitation is not infinity, right? The limitation is e to the APR times y. In other words, we have compound is 1 plus APR over n to the ny, right? That one yields to e to the APR times y, which means what? Which means 1 plus APR over n to the power n yields to e to the power APR. Right, you can exclude the effect of p, exclude the effect of the power y. Remaining is infinite approach we have, right? As n goes to infinity, the yield goes to e to the power APR, where e is some certain of number is 2.71818 approach to that on your calculator, right? That's the natural base. You will see a lot of that in your science major, right? In your science courses, like in physics, chemistry, or even biology, right? Geography also see that, probably, right? You have the E. Accumulated for years, P is starting principal, and your percentage rate as decimal, and Y is the what? Y is the number of years. Right, so let's see an example, right? Continuous compounding, you deposit $100 in an account, APR of 8% with continuous compounding, and asking for what is the amount you get after 10 years. Right, so continuous compounding is a little bit different formula, but the power a little bit shorter, right? So in that case, we get P is $100. Annual percentage rate is 8%. Term of years is 10 years. Right? I didn't put in other color. That's a mistake. So I put it this one to exclude it. E to the 0.08 times 10. It should be also a number, right? We have on your calculator e to the certain power. Right? So when you click it or when you find on your own calculator, you just do that, right? E to the certain power, that power is what? 0.08 times 10. Get 2.2255. $409.28. Right, that's 222.554098. If you keep it as the money, right, as final result, that's $222.55. Right. So that's about the simple and the compound interest. Right, and the formula is that, right? It's not that tricky, right? But just be careful, right? Something you can do calculation at first, then apply everything, right? Do step by step to keep all the numbers to have the least mistakes, all right? So that will be this unit. Thank you.